Hey guys, HackerSploit here, back again with another video. Welcome back to the TryHackMe series. In this video, we're going to be taking a look at the manual exploitation of ICE. Now, in the previous video, we went through the exploitation of ICE, but we went through it using metasploit, so a fair amount of it was automated, and there really wasn't any tinkering to be done in regards to the exploits and getting stuff to work. That being said, the previous video covered quite a few stages, one of them or two of them having to deal with reconnaissance and local enumeration, and that was primarily for the use of privilege escalation. But the final task, as you can see right over here, that entails an extra credit, involves manual exploitation. So it tells you right over here, explore manual exploitation via the exploit code found on ExploitDB. So they actually give us exploit code for this particular exploit, and remember, we're targeting the Icecast service, and that's a very important thing, because if we take a look at the nmap results, at least if I remember them correctly, you can see that is running Windows 7 Professional build 7601 service pack 1, which tells me immediately that this is or might be vulnerable to Eternal Blue. We are, however, not going to be taking a look at the Eternal Blue exploit, because that's not part of this challenge. We're instead focusing on the manual exploitation of the Icecast service. So again, you can just go through the summary here, and that essentially explains the importance of learning how to perform manual exploitation. So we'll check out the exploit that they've provided to us, and in the meantime, we can also run a quick search exploit for Icecast. And we can take a look at what exploits we have at our disclosure. So we can see that the target version that we're interested in is version 2.0.1, and the exploit code they've given us targets that particular version. That's a Windows 32 remote code execution exploit, and it looks like there are two versions here, which we also know through the search exploit search. You can see that we used this metasploit module right over here, which was also targeting 32-bit, which was also targeting 32-bit architecture. So what we'll do is, let's take a look at the exploit code that they've given us. So you can see that it looks like it has a shellcode add-on, which is expected, because that's I'm guessing that's the only way we're going to get a reverse shell if we use this exploit. So we can see it looks like the target port is set correctly, because through the nmap results we know that Icecast is running on port 8000. So that's interesting, and we can see that there is a remote connection initiated through the target OS, or you can see it's being run through Windows. If we take a look at any documentation, we have the shellcode right over here, which tells us web download and execution shellcode, which downloads http elitehaven.net netcat.exe. That's weird. So let's see what netcat shell or exe file it's downloading, which we can see the website doesn't work, which is sad. So it tells us this ncat spawns, that's an incorrect spelling there, a shell on port 9999. Okay, so it gives us the shellcode here, but it doesn't give us any instructions regarding the shellcode, not necessarily to generate the shellcode manually, but that is quite important, because that's where we specify the payload, because I'm guessing we're generating the shellcode using MSF Venom. It also doesn't give us any instructions regarding the bad characters we're supposed to exclude here. So yeah, so it looks like it doesn't give us any documentation. As for the usage, it looks like we provide the server IP and then the port once we've compiled this binary. So let's try and compile this binary here. Before we do that, I just want to see what the difference is with the second version of this exploit, which looks like an updated one that might have a few more features that we can use. So we'll open up the ExploitDB page here. And we can see this is a modded version, and it looks like the exploit will add an administrator account. Okay, right. So that's what it's doing. It's not giving us any other information regarding the shellcode, which is quite important in getting the initial reverse shell. So let's try and compile this exploit. So I'll just download it. and we can then move it. So I'll just move it from my downloads directory, and we want to move it 568.c into our current directory, and I'll analyze it using VS Code just so everything is clearer. So there we are. Okay, so it looks like yeah, because I just want to see if it compiles first, because there aren't any compilation instructions. So GCC 568, and we'll output that to 568, and we hit enter. Yeah, pretty much that's going to give us this error here. So again, one option we could try is we could actually try and convert the metasploit module, but I don't want to do that as of yet. What we'll do is let's see what information we can find regarding the compilation of this particular exploit. So sorry, let me just copy that correctly, because we copied that incorrectly there. So because there might be some compilation instructions online somewhere. So it looks like, let's check this out. That was posted on October 2004. And then there's the CV details, and then here that's a GitHub link. Let's check that out as well. And research labs, yeah, that looks good. And we also have a modded version here. So let's also take a look at that. So that's all day today. Yes, I'll hit agree. And looks like the IP is exposed here. That's weird. Anyway, this is a modded exploit. The date it was added, it was 2004. So I'm guessing there isn't much of a difference. If I try and download it, it doesn't allow me to save it. Let's try and open this up in a new link here. Yeah, it just takes me here. So open exploit. Yeah, so there isn't anything added to this particular exploit. It's essentially the modded version. That's the same exploit we're dealing with right now. We have the GitHub. This is Icecast header override buffer overflow RCE. Right, so Ice header override. This is the metasploit module. So hold on, let's see. Python 3 Icecast header override buffer overflow RCE, rewritten from this metasploit module. Right, so yeah, this has actually been rewritten in Python 3, but I can also see 568 edit.c. So this looks like a modified, right, so original exploit is here. Yeah, that is the original exploit that we actually cannot get to work. It says I could not get this to work, so I edited it according to the modified version, which is the second version. So this was the one that people are having an issue with, it looks like. So the shellcode is now executed, and to compile it, we simply just use GCC, and there aren't any special compilation requirements there. If we take a look at the shellcode, and yeah, there we go. So we now have instructions regarding how we can compile it using MSF Venom, and there's also an appropriation for the bad characters that's provided here. So that's cool. So what I'm going to do is I'm going to download this one. I'm not going to use the Python one, just to stay original. So we'll copy that, and we'll remove the old exploit here, and we'll just say wget, and we'll get this modified version. So that is called 568 edit C. So we'll open this one up, and we can then generate the shellcode. So I'll just toggle word wrap here, just so we have that nice and clear. So we'll generate the shellcode here, and we just need to change the L host. It looks like the payload is set to a Windows reverse shell, which is fine. We can also change that to a command shell if we want. And we just need to set L host, and the L port is set to port 443, which is interesting. So we'll leave that as it is. And if it causes issues, we can then generate our own. So I will copy the IP here, our local IP. Let me just confirm if that is correct. So ifconfig. Right, I need to run that with sudo, and hit enter 110.8.109.123. That is correct. Okay, so we can now go ahead and generate our shellcode. I'll just copy that one more time, just in case I don't have it. And as I said, we'll leave the L port as 443. That shouldn't cause any issue, at least in my estimation. And there we are. so that will run. I know I'm using Z shell right now. That usually causes quite a few issues. So what I'll do is I'll just open up bash here and I'll run this with bash. So we're going to run this right over here, because I know Z shell usually causes a few issues when I'm setting up my shell code. So let's hit enter, and that'll generate our shell code for us, and then we'll compile the exploit. Hopefully it works out of the box. So again, there we are. Looks like the shell code is generated. It used regardé, although we didn't specify the encoder. That's weird. Anyway, let's see if this works. We can then make changes as needed. So again, I'll just replace the shell code here, and we'll put that. I'll just paste that in the place there exactly. And yeah, looks like the bad characters were also excluded. And then of course we'll hit save, and we now can compile the exploit. So GCC 568, and we'll just call it 568 as usual, just so that I know what we're dealing with. chmod +8 +x 568, and then we need to set up our netcat reverse shell, so, or our listener, sorry. So netcat, I think we'll need permissions here. So sudo netcat nvlp 443, and yeah, that looks like that should be listening perfectly fine. And then we take a look at the exploit to run it, or the usage. We can see that the target port is fine. To run it, all we need to do is just provide the IP, I think. There we are, yeah, 568 IP. So the target IP. So I'll just go back to TryHackMe, and we'll copy that there. And all we need to do is run 568 and put in the IP and hit enter. So it sets the target port, and it sends the malformed data and says the server is vulnerable. And if we check that, and yeah, we got a shell. All right, so that's excellent. So this is just a normal reverse shell. So who am I? We are currently logged in as the user doc. So if I say net user, that will list out all the users on the system. So we have admin, and we want to get admin privileges. That's the goal here. We've already identified the flag, so I'm not going to be doing that. So we're now in the privilege escalation stage. Okay, so what we want to do now is let's try and enumerate information regarding the system, and of course we'll use system info. So system info, and we know a lot about the system already. So in order to get our local privilege escalation exploits or kernel level exploits, we're going to use system info in conjunction with Windows exploit suggester. So Windows exploit suggester is very similar to the suggester tool with metasploit, and what you need to do is you need to save the system information that is given to us by the system info command, and then the Windows exploit suggester will then use this information to give us potential privilege escalation exploits that we can then use. So I'll copy that, and what we'll do is I do actually have it on my system. I don't think so. So let me just close all of these useless links here, and we are going to search for Windows exploit suggester, and I think that's the one. I think there's an updated one as well. This is the one here. So using it is fairly simple. We just need to update or get the database of the latest exploits. And what version of Python does it run on? Because it's been a while since I've used this one. So it looks like it is it runs on looks like it runs on Python 2 or 3. This is just the documentation here. Yeah, so it looks like it's running on Python 3 if I'm not wrong. But yeah, we can actually just test it out for ourselves. So I'll just clone this repository, and we'll open this in here. So git clone, put that in there, and we'll wait for that to clone. CD Windows exploit suggester, So to run it, we need to update or get our initial database of exploits that will then be used to actually run against the system information that we've got. So update, I believe, right. So we need to run this with Python. Let's try Python 2 first. Python 2, yeah, that looks like it's working. So it gets the database in an Excel spreadsheet with the date, which is great. And then to run it, so we need to output system info into a file. So we'll create a new file here, and we'll put in the system information which I copied. I'll just copy it one more time. So we'll just copy the data tool there, and we'll save this as system info. Or just say sysinfo.txt, and we'll save it there. Okay, so that's sysinfo.txt saved. So we provide the database, and then we provide the system info argument, and then sysinfo.txt. Excellent. So we'll do that right now. Let me just see if my session is active. Yep, that's active, by the way. I'm pretty sure. Do we have permissions here? I don't think so. So I'll just go into the C drive. 1 second, and cd users, and we'll go into the user doc, and yeah, we'll just work through there. All right. So we can now say Python 2 database is going to be equal to 2020 1221, and then of course we say system info. That's going to be sysinfo. Did we save it within here? No, we didn't. So I'll just move it. So move sysinfo into Windows Exploit Suggester. We'll close that up, and we can then say sysinfo.txt and hit enter. All right. So it looks like it's working out of the box. Okay, and we get our potential exploits. So we're going to be looking for critical privilege escalation exploits here. And this one uses Kerberos, but we'll just go to the top. It looks like the ones at the top are going to be the latest versions, which if we go through them here, we can see these are just important. Let's go to the critical ones. Important, MS. I'm pretty sure if we're talking about Windows 7 service pack 1, we're going to be dealing with the MS14 exploits. So these are the ones I'm interested in. You can also see we also have I'm not sure this one works on Windows 7, but we'll work with MS14 first. So MS14 is elevation of privileges. So let's check out this exploit first. So that's MS14068, I believe. All right, so this is a Python exploit, and let's take a look at what information we can find regarding this particular exploit. So let's search Google here, and I'm not sure it works. It might actually work on Windows 7. So affected operating systems: Windows Vista, Windows Server 2008, Windows 7, 32-bit system service pack. It's not listed that here. There aren't any hot fixes installed on the system because we actually didn't see any here. Yeah, hot fixes only KB253111. Yeah, okay, so hold on. Let's just see if this is the one we're looking for. So Windows 7, then it gives us the link here. So just open that in a new tab. Let's see what that is in reference to. Well, I think I actually copied that incorrectly. Right, that's the URL here. So copy that one more time, open link in new tab. So that's KB301. Let's see yeah, that's not installed, so that might work. Let's take a look at some of the other exploits here that we currently have, which were in here. So that's 068. Exploit DB that uses Internet Explorer. And then of course we have 60 remote code execution. We don't want that. 058, that is remote code execution as well. We're looking for privilege escalation primarily, but let's check out this one as well. That uses metasploit. Interesting. So I'm not entirely sure what exploit we should use. Let's search for this exploit here. Search Google. Well, it looks like we have a GitHub link. So trigger an exploit CVE. It gives us the CVE code. Let's just take a look at this on Mitra. We have the URL, the disclosure URL from Microsoft. We can see that it affects Windows 7, obviously. Service pack right over here, critical, and it was patched in MS 14.015, I believe. Okay, so let's try out this one first. Do we have, because I don't want to compile this right now. Let's see if this works out, because we already have the pre-compiled one. So the usage is as follows: Win64, that's, I'm guessing, the exploit. Windows kernel exploits. This is under SecWiki. Yep, I'm familiar with this repository. So we need to, if we open the raw file, we should have Win64. It looks like they're using Armitage, well, actually Cobalt Strike. So to use it, we run the Win64 or Win32 exe and the whoami command, and that'll give us NT authority. Right. So this is a pre-built exploit. So what I'm going to do is I'll download this RAR file. Hit save, and looks like there's an issue here. File contains malware. Just open it anyway. So Windows 32, Windows 64. Okay, great. So what I'll do is I'll just open this up, and we'll go into downloads, and I'll just I'll cut this into documents, and I'll put this in here, and I'll extract that in here, and we will just well, as that extracted, there we are. I'll just copy win64.exe, and hopefully, let's see if this can actually work now. But we need to upload this to the target. So what method should we use? We're on Windows 7. Do we have the ability to execute PowerShell? Let's actually see if we can use cert util. Yeah, that the cert util is very, very cool, because you can essentially just download files directly, and cert util, yeah, so it looks like the syntax is quite simple. So cert util exe URL cache the file, which as the URL to the file, and then we save it as a particular file with its unique file name, or we can leave it as is. So what I'll do is let's see if we still have a connection here. There we are. So we'll go into our desktop, and what we'll do now is we will actually have to set up our simple web server using simple HTTP with Python. So just take a step back, because our win64.exe exploit is here. That should run straight out of the box. But I want to see if it works, because we'll then need to get a reverse shell. We'll have to generate that using MSF Venom. And then of course we need to upload that, and we should be able then to upload it and then execute it with this particular executable file. So we'll say sudo python python2, because I have both versions installed. So simple HTTP server, and we'll run this on port 80. Okay. And then we need to get our local IP, but before we do that, let me just get this command here. Let's modify it a little bit to our own options. So that is certutil URL cache, and we then say we want our IP, which is this one right here, because that's what it's going to be targeting, and the port is set to port 80, so that isn't an issue. And then we're setting this to win64 win64.exe. that's already set for us, and we'll just call it again win64.exe, and we'll copy this and we'll run this on our target. So we'll just paste that in here and hit enter. Hopefully certutil is active, because it's much quicker than using PowerShell or any of the other transfer methods. So yeah, that is online. And yeah, it completed successfully. Let's see if it got the file. So win64.exe. So to test the exploit, let's go back here. We also have a trigger. That's interesting. Okay, so to test the exploit, we simply say who am I, just to see if it's working. So this is almost like a set user ID binary. So if we say win64.exe, who am I, and you can see it tells us we're NT authority. And again, we know that this will work as intended if we get a shell, but currently if I say who am I, you can see we're still logged in as dark. Okay, so we now need to generate a we now need to generate a reverse shell and then upload it, and then we'll run this with the binary or with the executable that will then give us a reverse shell with NT authority permissions. Okay, so in order to generate this, we'll just use MSF Venom. We already know all the relevant information, and we'll just set up another listener on a different port. So to do that, we'll just say this. Let me just open up a new tab here. We'll leave this as is. We'll leave the web server running. So we'll say we're in the ICE directory. So MSF Venom. We know it's a Windows payload, obviously. So Windows, and the target architecture we're looking for is x64. And then we're looking for shell, reverse, TCP. We can obviously try HTTP if this doesn't work. And then, of course, the L host is the IP, which again are not intuitive at all. So I have to keep copying them because I'll make a mistake and forget it. So L port, we'll set this to 8080. And we then say the format is going to be equal to exe. We don't want to use any encoders because Windows Defender and Windows Firewall are disabled, I believe, on this machine, as far as I read. I might be wrong, so don't quote me on that. So output, and we'll just call this shell.exe. And we'll hit enter, let that generate for us, and we should be able to run this. We should be able to get this using the same certutil command or utility. So it's generated there. So shell.exe. We then want to set up a netcat listener. So netcat nvlp 8080. Hit enter. That's going to be listening on that there, and then of course, as I said, we'll use this same we'll use this same command here, but we'll replace this with shell, and we'll just call it so shell.exe, and we'll replace this with shell, and we should be good to go. So I'll copy this. We still have the web server running, which is using the Python module, and we'll just use certutil here, and it looks like it's completed. And we have the listener running on port 8080. So now we need to say win64.exe, and then we say shell.exe. Hit enter, and we get a reverse shell. If I say who am I, we can see I'm NT authority, and we now have administrative privileges. So that is manual exploitation in a nutshell. Of course, we haven't written or modified the exploits too much. We've just changed shellcode. I'm going to be taking you through how to convert metasploit modules into Python, because I actually saw that being done here, and I think that's a good idea because it's always helpful to actually understand how to convert a metasploit module. Where was that? Here? I think that was here. Right. So again, the reason I didn't go through the Python code is because it's going to really be very similar to, yeah, you can see it's very simple writing it in Python. So metasploit modules are written in Ruby, and there is a method or structure to this. So we can actually do it using I'll actually show you how to do that using Python. There's plenty of resources on that, so I'll take you through that as well. And then of course, we're going to be taking a look at the next box, which is again, which will teach us more about alternative exploitation methods, which is Blaster. So we'll be looking at that next. I hope you guys found this helpful. If you have any questions or suggestions, let me know in the comment section or on our social networks. You can reach us on either Twitter or LinkedIn. Our username is HackerSploit. If you also want to engage in a discussion regarding this particular video and this particular box, you can join in our forums at forum.hackersploit.org. A link to the discussion thread for this particular video and this particular room will be added in the comment section. It'll be a pinned comment, so you can check that out for yourself if you want to engage in a deeper conversation as opposed to typing in comments in the comment section. And I can answer your questions much easier there. So as I said, that's going to be it for this video, and I'll be seeing you in the next video. I just want to take a moment to thank all our Patreons at patreon.com/hackersploit for all the support. Your support and help is truly appreciated. You keep us making newer and fresher and better content. So I just want to say thank you to all the Patreons. So thank you, Murph the Surf, Daniel Bork, Jonathan Kyle, Adam Mack, Jamal Guillory, Dafim Bari, Jeremy Nikolai, Mary Hara, Max Chow, Dustin Umpress, Michael Hubbard, and Jerry Speds.